So, welcome to our project. This is Team 3, Team Salaar, and our project is Phytora. Go to the next slide. So, going over the agenda and everything that we will cover in this presentation, it will go from the team member roles and responsibilities to the project description, improvements made from the professor through his feedback, teamwork agreement, personas, our MVP, technologies used, algorithms used, the diagrams that go with our project, our Sprint 2 recap, product backlog, Sprint 3 backlog, Sprint 3 test cases, our stories, our stories that haven't been completed, our metrics, our retrospective, into our demo for Sprint 3, and in our GitHub link and live application demo. So into the team members' roles and responsibilities.
And when coming to machine learning engineer, me and Karthik is taking care of machine learning part, and coming to the back end and developer part, I mean Krishna Kishore and Gopi Krishna is going to take care of it.
Hi everyone, myself Krishna Sharma. I'll be working as a backend developer for this project.
Hi everyone, I'm Gopi Krishna. I was working as backend developer for this project.
Hi everyone, I'm Sai Priya Rampudi. I'm working as a front-end developer for this project.
Hello everyone, I'm Nagatik Potro. I'm working as a machine learning engineer for this project.
I'm Paul Morales. I'll be the front end developer.
Hi everyone, this is Nikita Apula. I'm working as a backend developer in QA.
Hello everyone, I'm working as a front-end developer. My name is Nalakshmi Nara for this project.
So into our project description, our project, as we know, we named it Phytora, is for farmers and agriculture researchers. So who this project is really for, it is for the farmers who are in need of an efficient and cost-effective method to detect apple and tree diseases, and mainly all plant diseases. So the AI-based plant disease detection system, we're using a deep learning powered solution, and this is helping to identify diseases like scab and rust early, which is very important as it will prevent a lot of crop loss. This is unlike traditional manual inspection methods, as we will be using AI as mentioned before, and our application leverages CNN to provide fast, accurate, and automated disease classifications. This way, we know that our project will be effective and trustworthy. The benefit outcomes, like I mentioned before, early detection. This will help these farmers and agriculture researchers uh, stop it at its root so it doesn't become more costly in the future. Cost effectiveness, eliminate the need for frequent manual inspections. High accuracy, as I mentioned before, we're using AI and deep learning models, so this will minimize misdiagnosis. It's very scalable, so as the farmer agriculture researcher scales their business, this application can scale with them. And is very user friendly, has a simple interface, and interaction is made simple for the user. So we can go to the next slide. So into the improvements. Starting with the improvements, we made a lot of fixes to our wiki page, making links work. Before we had some links that were dead links that didn't take you to anything, so now we fixed those. We also adjusted the diagrams to be a lot more legible for the user. So we had issues before with making them horizontal when they should have been vertically and vice versa. Next improvement was adding total story points from completed slide. We had to make adjustments to how many story points we were going to follow during this project. And finally, adding APA slide into the team working agreement. So for the team working agreement, we had 8 points that we followed by. First, the purpose and scope to understand exactly what we're doing and what our application is meant for. Into the roles and responsibilities, as we mentioned before, we had front end developer, back end developer, machine learning, and QA. That was our split. Into number 3 was a sprint planning and retrospective. So we made sure that our sprint ends on Monday and it goes into our retrospective, and the sprint planning was Wednesdays. 4, we kept good communication. We leveraged WhatsApp for daily updates, Google Meets. We use Zoom as well, and task management such as Trello to make tasks visible and make ourselves accountable. Into development and workflow, we used GitHub to make sure that we were keeping track of everything we were doing and all our changes. Testing and quality assurance, we implemented unit and integration tests just to make sure our code was running as we wanted to. And of course, deployment, so making sure that our deployments were stable. Into accountability and conflict resolution, so all team members were made responsible for reporting blockers and working on them. Any issues were discussed and resolved within the team, so we would collaborate on any issues so one member didn't feel responsible for everything. And repeated delays and unresponsibles may result in task reassignments, so making sure that we didn't have any delays and we made sure that our deadlines were our main priority. Into work hours and availability, we all committed 10 to 15 hours per week, but sometimes more to make sure that our goals were being hit. Work was flexible, but tasks were aligned with the sprint goals. So making sure that everything we were working on was aligned with what our goals were for that sprint specifically. And eight, into our agreement and commitment, all members agreed to uphold this agreement and this teamwork and agreement. And this has helped us make it all the way to this part of the application where we're ready for the final deployment.
Yeah. Coming to the personas, and former John Cotter is taking care of the plans, so he's going to cultivate apple trees. So his age is 45 and the occupation is former. He's from Washington DC and he's 20 years old, and he's worried about the pain points. He's relies on manual disease inspection, which is time consuming and error prone. Finds it hard to differentiate between early stage symptoms of apple scab and rust and high costs for hiring agricultural experts and consultants. And coming to the needs and expectations for the farmer is a mobile friendly app or any web application which is usually upload the pictures of the plants and to detect the image. I mean, detect the disease of the image. And we are using AI driven advisory system as well, so suggesting treatment solutions for different disease stages. And how our product helps him is automated disease detection reduces the guesswork and ensures timely intervention and provides step-by-step guidance on disease management. And coming to the another persona, and she's Amy Jo, and she's 38 years old. She's a pathologist and a researcher. She's from California, and the research is focused on AI-based plant disease detection and crop disease resistance. So pain points is discussing about needs large high quality data sets to improve the diseases classification models and the variability in disease symptoms like color, shape, and size. Makes model training and challenging. And coming to the needs and expectations, she used to access labeled image data set for improving AI accuracy and cloud-based dashboard with insights into disease occurrences across the different regions. And our product helps her to provide real-time disease detection data, aiding in research and policy recommendations, and offers a machine learning training platform for researchers and helps predict disease outbreaks and all. I'm coming to the another person, and he's the guy. He owns a company, and his name is Michael Rodriguez. His age is 32, and he's CEO of smart farming startup. He's from Texas. The pain points is going to be farmers are hesitant to adopt AI-based solutions due to some trust issues and cost concerns. So he's going to taking care of all these things. He's helping farmers to make comfortable with the application like web application or any app. And he needs some a lightweight AI model that can be embedded in farm drones and IoT devices and market validation. I mean, he wants some market validation data to demonstrate AI's effectiveness in reducing crop losses and all. And his product helps provides real-time analytics and reporting tools for farm management as well. Yep. Come to the next slide. And we are coming to the minimal viable product. This is the, I mean, thing how it works like. I mean, detecting the apple deceased leaf. After that, detecting the, I mean, taking the picture, we can upload to the web portal or any application. After that, it is going to disease, I mean, detect the disease. The system analyzes the uploaded image and automatically identifies the disease After that, AI model will give you the suggestion as per the CNN. I mean, the suggestion as per the data set matched to the exact right image to get rid of the disease. And after giving the right image, the instant diagnosis is going to taking care of the researcher. That's it for the the thing going to happen, and the technologies is going to take care of by
Hi,
Gopi Krishna.
hi everyone. So as for the technologies, we are using 8 technologies. So for the first part, where we'll be going for the front end. So for the front end, we are using Next.js. It's a React platform, a React framework for building fast, scalable, SEO-friendly web apps. And we are using Node.js, which is a JavaScript runtime enabling backend development with high performance. And for the backend part, we are using Fast API and PyTorch. As for the Fast API, it's like high performance and Python framework for building modern web API, which is very quick. And as for the PyTorch, where it's an open source deep learning library for training neural network models. So for the database, we are using PostgreSQL for it's mostly used for saving the data. It's an advanced open source relation database supporting complex queries and transactions. So for the coding part, we are using Visual Studio Code. Most of you might have known it. It's a lightweight, powerful code editor with extensions and debugging support. And next, we are using GitHub. It's a cloud platform for version control, collaboration, and code repository code, which is mostly used by everyone for the exchanging of the codes and everything. Next, we are using Vercel. It's a front-end hosting platform with automatic deployments and global CDN integration. Next, we are using next slide. Next, we are going for the orbital. So our system utilizes efficient net, which is one of the best CNN network to detect plant disease accurately. The efficient net adjusts the depth with the resolution for better performance. Transfer learning improves accuracy, while fast APIs enable real-time efficient prediction, yielding rapid, accurate, and resourceful frugal diseases identification for farmers, researchers, and agriculture professionals. Next slide.
Coming to the diagrams, first is the architecture diagram. The architecture diagram shows the fundamental structure of a Vitora system. Here we are detailing the interactions between the various components. The process begins with the farmer who uploads the image through the Next.js frontend, and the request is sent to the Fast API backend, which acts as a system core processing unit, and the backend forwards the image to a PyTorch based machine learning model, and it's responsible for the analyzing the image and detecting the any plant diseases. Once the model returns to the diagnosis, the backend stores the results in a PostgreSQL database. It's for a record keeping and retrieval. Finally, the processor data is sent back to the front end, which is allowing the farmer to view the results whether the leaf is uh, healthy or not. Next, coming to the context diagram, it provides a high level overview of how the Python application interacts with the external entities, and the primary user of the system is a farmer who uploads the and image of a potentially diseased plant, and the image is processed within a Python application, which is leverages and AI to analyze the detect the diseases. Once the analysis is completed, the results is including the identified disease and confidence level are stored in the PostgreSQL database for the future reference. The application is also deployed via Vercel to make it easily and with an internet connection. This context diagram effectively illustrates how data flows within the system and how different components interact to deliver results. Coming to the ER diagram, the entity relationship diagram, it represents the data schema of the Python system. It's showing the how different entities are structured and connected. And the systems consists of multiple entities, including users, images, diseases, and results. Each form, and here also each farmer is identified as a user who can upload multiple images which are stored with relevant metadata such as timestamps, image paths. The disease entity contains predefined classifications of a plant diseases, which the machine learning model references during analysis. And once the image is analyzed, the results come back to the entity logs with the disease detection with the confidence score. and and the relationships ensure structured and efficient data storage enable quick retrieval of past analysis. Coming to the next diagram, sequence diagram. The sequence diagram shows the step-by-step interaction between the different components of a PyTorch system during the disease detection process. The process begins with the same farmer who uploads the image through the front-end interface. The front-end, then the second it sends to the image to the backend API, which processes the request and forwards to the AI model for diseases analysis. If the model examines the image and predict the diseases and return the diseases with a name along with the confidence scores, these results is logged in the database and ensuring the both the image and its corresponding analysis are stored. Once the backend sends the processor result back to the front end, where it is displayed to the former. And finally these diagrams shows the visualize the end-to-end workflow of process of disease detection process. And coming to the next diagram, state diagram, it represents the different states of an image goes through the during processing. The process starts with the image, and once the image is uploaded and it pre-processed, it meets the required format and quality for analysis. And the analysis state is where the AI model of image of the disease detection. If the image is valid, the result is also successfully stored in the database. If the if the image is not valid, it sends the system flags, it shows an error, and it does not proceed with the analysis. Finally, this diagram helps in understanding the life cycle of an image within the system. Coming to the class diagram, the class diagram defines the key components and functionalities of PyTorch system using an object-oriented approach. The main class includes format, front-end, back-end, AI, and the database. The former class has methods to upload the image and view the results. The front-end class manages the user interface, displaying the upload forms and the results. The backend class handles the processing, calling the AI models, and the saving the results. The AI model includes the function to predict the diseases with the based on input image. Finally, the database class is responsible for storing images and results. These diagrams provide a clear view of how different classes are interact to ensure smooth functionality. Thank you.
Hello guys, I will be driving you through the product backlog. Coming to the next slide, here is the quick recap of the Sprint 2 planning. In the Sprint 2, we have made the system smarter by teaching it to tell the difference between the scrub and rust when the leaf is unhealthy. So we added the confidence score and the basic advice, so farmers not only know what's wrong but also what to do next. So we also tightened things up behind the scenes by making sure only the real leaf was images were accepted, and we also added the automated tests to keep the core features stable as we keep building. Coming to the next slide. So here the product backlog. Uh, so In the sprint one, building the foundation for the disease detection. In the sprint one, we have focused on the improvising the farmers with the basic yet essential tools for the disease detection. Like the farmers can easily upload images to their like to the of the leaves from their either their desktop or mobile devices. So these images are securely stored in the backend, ensuring the accessibility and the reliability. And the quick diagnosis. Once the image was uploaded, the system analyzes the leaf and tells the farmers whether it's healthy or diseased, giving them the instant feedback so it can take action if necessary. Preparing the images for the AI analysis to ensure accurate detection. Each image is where the pre-processed and noise is removed and the dimensions are standardized to fit the AI model perfectly. So image was logging for the track. So every image is uploaded logged for PostgreSQL, complete the timestamps and the image URL and the diagnosis result. This keeps everything organized and auditing for the system improvement. Coming to the next slide. Coming to the next slide, the CI/CD pipeline system to streamline development will set up the CI/CD pipeline to automatic deploy code changes to version. So this eliminates the need of manual deployment, ensuring the quicker updates whenever changes to push to the main batch. So identifying in the sprint two, making disease detection smarter. So by identifying the specific diseases, the system takes disease detection further by specific issues like scrub or rust. Like this helps farmers to understand exactly what's affecting their crops. So the confidence score, each result comes with the confidence score gives the farmers insight into how the reliable to the diagnosis is helping them to inform decision. So the practical advice, once the disease were detected, the farmers can receive the actionable advice like recommending fungicides so they can know the next step what to do next. So coming to the next slide. Yeah, here we improved the image validation. In this in system now verifies the uploaded images to ensure they are valid leaf photos. So non-leaf images are promptly rejected with the clear error image. So saving valuable resources by avoiding unnecessary processing. The strengthen the reliability. Though to maintain functionality test cases, we have added for all the core API upload detects and classify, ensuring the system remains robust even the changes are made. Each API are now on at least three automated tests. And in the sprint three enhancing, we have tracking disease history for the farmers. Now access detection history page was displayed by the post uploads to complete the timestamps and diagnosis results. This feature allows for the better monitoring and the disease trends over time. So the time saving batch was uploaded, the time stream flow workflow for the farmers can upload the images per up to 5 leaf at once. So speeding up the scanning process and improving the efficiency on the field. And coming to the next slide, the usability and the performance enhancement making app mobile friendly. As a farmer, you will be able to use the app seamlessly in your mobile. So while in the field, so the goal is to make the app fully responsive on the mobile browser. So it feels as smoother as innovative and the phone does on the desktop as well as on the desktop. So for faster disease detection, nobody likes waiting for the results. So the AI model is being optimized to deliver the disease detection result in less than 3 seconds per image. So the error logging for the better maintenance. If it's something ever goes wrong, likely if like detection failure, the developers will know right away. So the error will be logged with the key details, the timestamp images, and the information and the error message. so the team can fix the issue quickly as soon as possible and keep the system run smoothly. Thank you, guys.
Coming to sprint backlog, so we planned a list of tasks that we need to complete for the sprint 3. So we completed those tasks. We can see here uh, the sprint backlog over here. Yeah, coming to the next, yes. So we can see the user story over here and the technical story as well. And coming to the first user story, the farmer wants to see the past uploads and the result as well. So as a farmer, once he logged in through the app, so he can able to see whatever he uploaded and the disease and the timestamp as well. So he can keep track on the disease and the history as well. And the app must be show the uploads within the timestamp and result as well. And the next user story, the farmer wants to upload multiple images at the same time. So we can save the time during the scanning as well. So the app must supporting the uploading 5 images at same time. And the next user story, make sure the app works well on the mobile phones, and if user wants to open in other websites also, like other laptops, wherever he wants to use, so the app is working properly, so then the farmer can use directly in their fields as well. So the it is must like the app is working properly and the fully responsive on the mobile browsers as well. And the next technical story, uh, so to improve the AI model, like improving AI model to detect faster. So no need to wait for too long. So the former, no need to wait the format for too long to get the result and all. So each image should be processed in the less than 3 seconds. So and next one, coming to the next user story, we can see the log errors. And yeah, those are properly into the post ZRE database. So developer can we have the developers, they can easily identify and they can find it and we can fix the problems as well. So each error must be included in the within the timestamp and image and URL as well, and the error message. So these all are regarding our user stories and the technical stories which we performed in the sprint 3. And coming to the test cases, so after finishing the user stories like and test cases, we plan technical stories, we plan to test those test cases. So we created a list of test cases for each feature. So we can see as per the user story and the technical story, the history page. So we uploaded a leaf image and checked it. So it is appearing correctly in the history as well. So we can see the right stamp as well as the result. And the next one, here we can see the status. It is passed because we got the appropriate and accurate timestamp result along with the image and the history as well. And next one, we uploaded multiple images at over a same time. So we uploaded 5 images at the same time, and we got it showed up the same history in a correct order as well. So again, the status is passed. And coming to, we can see the batch upload. That doesn't mean like user as I said, if user wants to upload multiple images like former, so we tried uploading 3 images at once and all images were passed and showed the correct and exact result. So the status is passed, and we test another, like we try to upload 6 images, even though the limit is the 5. To check if the system shows an error or not, we checked 6 images. So it is correctly showed the error message as well. So yeah, the status is passed over here. And the next one is mobile responses. We open the app in our mobile browser to see whether the layout look good and whether it is working properly, or if we have any uh, issues or not. And everything looked fine and the status is passed over here and the test case is passed. And next one, we uploaded an image using the mobile device to make sure the upload and detection worked smoothly or not. Yes, it is working properly, and yeah, this test case is also passed. And the next one, model optimization. So we tested, like we uploaded a leaf image to check how fast the AI model is giving the detection, checking it and giving the exact result. So yes, it is working properly, and the result came back within the less than 3 seconds, as we discussed. So and the test case is passed over here. So till now we checked, we included imaging uploads and history tracking and batch uploads, mobile use and speed detection system. So all tests are passed over here, and our app is working properly till now. Move to the next. Okay. Yes. Coming to the next text uh, case, we have model optimization. We uploaded multiple images together and checked whether the image was processed or not. We have to get that image. We have to get that image within the 3 seconds. So yeah, it is processed within the 3 seconds. Everything was processed quickly, and as we accepted, and we got exact result. So the test case is passed over here. The next one, error logging and manual failure. So we manually triggered a detection failure to see whether the system is properly throwing the errors or showing the errors or not. Yes, the error was logged correctly into the post ZRE with the detailed timestamp as well as image URL and error message. So here the error logging and malware failure test case is also passed. And the error logging and the bad input. So we gave a system bad input on purpose to see if the records of the error is correct or not. The system is created an error with all required information, and it is giving exact output like, hey, it is a bad input. So and this is like the status is passed over here. Yes, we checked all the like based on the test cases, manual failure, and whether it is checking the images partially or not. We checked all the records, and the system is throwing the exact and accurate output. So all test cases were successfully passed till now. This is about our test cases, and coming to the next one, user stories. Yes, Sprint 3 user stories completed as per the Sprint backlog as well as user stories. We checked everything, so we can see the user stories as well as the technical stories over here. We checked the history page and batch uploaded, mobile responsive, and the model optimization, error logging. So for the history page, we got accurate and exact output. So the status was completed, and we reached our user story like it was completed. And next batch uploaded, yes, we tested that. We tested with the multiple images, and we like the system passed all exactly, like it showed up exact result over there. So we passed the status is passed. And mobile response also, yeah, user can open wherever you want, wherever he wants to open, and he can directly open and he can directly upload the image, and he can check it. So even if the system is throwing, like, it is working properly. So the status is passed over here. Mobile model optimization also, it is showing accurate result within the less time. Yes, and the error logging also, yes, it is showing a exact error even if we uploaded the bad input, or if we are uploading any other images also. Yes, the user stories also completed. Yeah, this is about our Sprint 3 user stories. Yeah, we are done. Move to Lakshmi.
Hello everyone, metrics. For this sprint also we used team velocity and burndown chart to track our progress, and which gives us clear view of how quickly we are doing our tasks and whether we are on pace to complete everything. For this sprint, the team successfully completed 22 stories, which explains strong execution and efficiency. Can you move the slide? Historical team velocity, it's the average amount of work we work during this sprint, and it is based on the past sprints also, like predicting how much work our team can handle in upcoming sprints. These releases, this was based on planning releases and setting realistic deadlines. And our team is also tracking our improvement and staying consistency, or if there is anything we can be slow down for the further what we can use for the tools and all that. And for sprint one, we use 18 story points, which shows we planned everything and we executed properly, like we delivered exactly what we promised in this one. And for sprint two, we use for 22 story points, which was more work compared to the sprint one. Like it shows us our increased capacity at we still managed to complete 100%. It is showing our team perfect consistency. And for sprint 3, we didn't add any more story points. We do same as sprint 2, which shows like a no decrease in the performance. Can you move the slide? Okay, button chart, vertical line shows how many story points are there for the sprint, and horizontal line shows how many days which we take. In this sprint, mostly we stayed closely to the ideal line only, which shows that our button chart will eventually go to 0 by the end of the day. We started initially with a 1 point, but slowly we made it like a more, we didn't take much time. There is no delay or no blocker issues in the sprint. So it was actually good, and which shows smooth execution with no backlog left, and we perfectly deliver work, so which shows consistency reduced. And we have planned and executed sprint planning on team coordination also good for this sprint. Can you move the slide? Completed and committed ratios for sprint 3 also is 100% by delivering all 22 committed story points. This highlights strong planning, execution, and collaboration throughout the sprint. Can you move? Based on all sprints, average completed and committed ratio, our team delivered exactly what was planned in every sprint, and no underwork, under delivery, or over deliveries in the sprint. In sprint 1, all 18 story points, and sprint 2, 22 points, sprint 3 also 23 points, which shows us sprint planning and accurate estimation and strong execution discipline. So our team can be trusted with the communication and very mature and agile practices. Retrospective. In this, what went well is team members are helping each other regularly, and we also test cases also improved in this. And machine learning algorithm is successfully developed, good communication within the team based on by implementing all the agile practices, backend APIs and machine learning work well together. And we also have regular updates in GitHub to help our progress. And project was finished on time. And what can be improved? We are thinking to add more updates on the Jira on daily basis, and we are planning more schedule tools could be improved, and time management could have been better, and working on team velocity, sprint velocity, and story points, clearing blockers, and sometimes work also piled up at the end. What are the action items for this sprint is using better tools for scheduling and tracking, implementing a label on every task, updates or progress, and having small deployments for each and every improvement, and optimization of code for future perspective, and encouraging quick blockers update during stand-ups. That's it, guys. From here, Karthik will take on. Thank you, everyone.
So hello everyone, this is the project demo. Here you can see the screenshot of the application. It's only the dashboard. Here you can see the welcome to Fedora page, scan now, and basic icons here. And here is a detection page. Here you can upload the image where the leaf detection will be taken place. You have to upload a image here like this, and you have to analyze it. After analyzing, it will shows you a output stating the disease, what kind of disease is that, and what is the confidence levels, and what kind of precautions you have to take. This time you can upload up to 5 images. below 5 images or up to 5 images. It will give you an individual report whether it is healthy or not, and what kind of disease you have, and the confidence level to the each leaf. And this is an about page of our website. Here you can see our mission, and what is the project about, what is Fitora and everything. Here you can see the kind of diseases, the basic two kind of disease, apple scab and apple rust. You can see the symptoms and management of them. This is an API slide. Here we have 4 section: purpose, localhost URL, example request, and example response. In the first one, we are uploading an image. This is a post request. It will give you a localhost page with 3000, and here we are uploading a file, and it will create a some example response of upload IDs 123. And the next one, we are running a detection, and it will get a post request detect. And here you can see the example request upload IDs, and here is the detection is going on in the responses. It will give you a status, like if the image is healthy, it will give a healthy, and if it is unhealthy, it will give the status as unhealthy. And here it is in the third section, it is classifying the result. But in this time we are it's going through a get request, classifying the result. There will be no example request, but the response will be taken place. It will give you a confidence level and what kind of disease is that. Here you can see the view history purpose. It is a get request from a local host. And here in the example request, here you can see the author header and history response, what kind how many times you analyzed the leaf and how many leaves you have analyzed. And get advice purpose, here it is a get request from localhost. In the example response, you can see what kind of advices you have. It will prepare a response and will send back it to the user. And it is here it is, you can see the post request localhost to validate an image. Here you can to upload an image. It will give an example response of whether it is a leaf or not in true or false manner. Here is a Wikipedia page. You can see what kind of tools we have used, and uh, our team members and our work and everything. Let's go to the demo quickly. First of all, you have to download an API from Open API like ChatGPT or anything else. You have to create a .environment file in front end, and you have to upload a API key here. You have to run that successfully. After that, you have to go to the through terminal. You have to go to the file in the front end file. You have to use an NPI command. It will give you a local host here. Here it gave me HTTP localhost 3004 3004. And if you paste that in Google, here you can see the dashboard of our project. Here you can key scan now, view reports and recent scans we have done. If you go down, you have a quick action button, new scan and view history. The next page is a detection page. Here you have to upload a image. Here we stated that upload of your apple leaves for AI powered disease detection. You can upload up to 5 images at once, or below 5 images. And the next thing is a history. Here you can, I have done recently of uploading some images. Here you can see my history, what kind of leaves I have uploaded and what kind of disease it have, and the confidence levels and the advices. Here is a about page of about page. This is about Fitora. It is an innovative AI powered solution for early detection and management of apple tree diseases, helping farmers to protect their crops and improve yields. Here is our mission. We believe in the power of technology to transform agriculture. Our mission is to artificial intelligence and computer vision to help farmers detect plant diseases early and reduce pesticide use and implement sustainable farming practices. It works in a three-step manner. Katora works in a three-step manner. First one is capture, second one is analyze, third one is act. It will capture a photo and you have to upload that using a smartphone or desktop, anything else. And later it will the AI model will analyze the leaf, and it will detect the signs of diseases like apple scab, rust, or any other common pathogens. And the next step is act step. Here you will receive instant results whether it is a disease or not, and the confidence score, and the actionable treatment and recommendations you have to take in the future. Here is our technology. computer vision advanced image recognition algorithm that can be identify subtle signs of disease that might be missed by the human eye. And also deep learning, it's a neural network trained on thousands of images onto accurately classify different types of plant diseases with high confidence. And the next technology, real-time analysis, here the fast processing that deliver results within seconds, allowing for immediate action to address detected issues. And the treatment database, comprehensive database of treatment recommendation based on latest agriculture research and best practices. It's our team member. We kept all our team members here in a about page. Here also, if you have any questions or something else, you have contacts, and we also prepared FAQ questions. This is the diseases page. There is a common leaf diseases, apple scab disease, and apple rust disease. If you see in apple scab disease, there are three symptoms and particular management we have to take. The symptoms are olive green or brown spots on the leaves, or dark scabby lesions on fruit, premature leaf drop. Here, the managements are apply fungicide specifically targeting scab, remove fallen leaves to reduce spread, prune trees to improve air circulation, plant scab resistant varieties. Apple rust disease. Here are the symptoms: bright orange yellow spots on leaves, orange projections on leaf undersides, reduced fruit quality. And the managements are applying a fungicide designed for rust diseases, removing nearby juniper plants if present, plant rust resistant apple varieties. So, this is all the diseases page. If we go to the home page, now let's scan some images ourselves. I'm going to the scan section. So, I'm gonna scan. I'm gonna upload 5 images. Yeah. So after uploading the 5 images, you have to press analyze button. In the meantime, it will analyze all the 5 images and will provide you an output. You can see here step by step, it's taking the processing 4 of 5 plant leaves. Yeah. Yeah, you can see it gave an individual leaf report to us. You can see the 5 leaves here on the top, and whether it is a healthy or not, the confidence level, and the advice. The first leaf is healthy leaf, so the confidence level is 95. Advice is continue regular maintenance and monitoring. And the second leaf here, it is a unhealthy leaf. Here you can see the disease is stated as apple rust disease. The confidence is 95%, and the advice you have to take is apply fungicide designed for rust diseases, remove nearby juniper plants if present. So if you go to the third leaf, same, the apple rust. And the fourth leaf is different. It's apple scab disease. The confidence level is 90%. And the advice you have to take is apply fungicide specifically targeting scab, remove fallen leaf to reduce spread. Oh, this is analysis has failed because the image is not clear. So here you can also see, you can also view the all records, all the scans you have seen. This is page 1 of 2. I also have page 2. Here we have a remaining sites. Here, if you see, if the leaf is healthy, it will show us as a green spot and the healthy leaf. If it is a unhealthy leaf, it will show a red spot and the type of disease it have. It will also give you the time and date when you scanned the leaf and when is your output came, and the confidence level. If you don't want if you don't want any particular leaves, or if you're done with the leaf information, you can delete the history here by clicking the delete button here. If you want to start a new scan, you can go directly from here, or if you're gonna go to the dashboard, you can see here scan now. And this is the total, and you can also access our history in 2 ways. Here in the dashboard, can also see you can see view all scans. It will take you to the history page, or you can directly access from the top history page. That's all. You can clear all the history by one click here by clicking on clear all. That's it. Yeah, thank you.
Thank you, everyone.
Thank you, everyone.
Thank you, everyone.